In today's lesson, we'll be learning about radioisotopes. Now, many elements have multiple isotopes. What isotopes are? They're where different forms of an element have the same number of protons but a different number of neutrons. So in other words, their atomic number is the same but their atomic mass is different. So we can see in the picture here, these are three isotopes of the element carbon. The carbon that you're familiar with would be carbon-12, and that's got 6 protons and 6 neutrons. So most of the carbon that's on Earth is this type of carbon with 6 protons and 6 neutrons. That type of carbon is stable. There are two other isotopes of carbon, carbon-13 and carbon-14. In carbon-13 there are 7 neutrons and 6 protons, and in carbon-14 there are 8 neutrons and 6 protons. Both carbon-13 and carbon-14 are unstable isotopes. So most elements have some isotopes that are stable. So for example, as previously mentioned, carbon-12 is stable. But there are also many isotopes that are unstable. The isotopes that are unstable, they're called radioisotopes. And what happens with those is that they don't stay as the elements that they start out. They actually gradually decay into another element. So in the case of carbon-14, over time it is going to decay into nitrogen-14. As it decays into nitrogen-14, it also emits beta radiation. So different types of radioisotopes will emit different types of radiation, and also it will take different amounts of time for different radioisotopes to decay into other isotopes. The half-life of a radioisotope, that's a measure of how long that process takes, and we'll talk about that in a further lesson. Okay, so what this diagram shows us is it helps us to decide whether isotopes are stable or unstable. Now, first of all, any element that's got an atomic number that is greater than 82, so any isotope with an atomic number greater than 82 is automatically unstable. Those atoms are very large and they're not very stable. For the other isotopes, it depends on the ratio of protons to neutrons. So we can see in this graph over here that the elements that have got a small atomic mass, the stable ratio is going to be basically 1:1. If they've got a ratio of protons to neutrons that's about 1:1, they'll basically be stable. On the other hand, for the larger atom, that ratio changes slightly. And we can see in this diagram over here that the zone of stability is colored red, and then we've also got a whole lot of isotopes that are in the blue region, and those are unstable. And that concludes our introduction to isotopes.